Welcome to the last Ask Confluent of 2019, where we answer questions from the internet. I'm your host, Gwen Shapira, and with me today I have staff engineer at Confluent, Vinos Chandar. And Vinos is joining us from Uber, and he joined us to be one of the main drivers behind the ksqlDB project. Is it ksqlDB? ksqlDB?
ksqlDB.
ksqlDB projects. Which was recently announced and instantly became kind of an internet hit. We have 50,000 questions to answer about ksqlDB in this show. I also want to point out that Vinos here is the originator of the Apache hoodie project, and he's wearing a hoodie. He's actually wearing a hoodie.
Hoodie, yeah.
And since we all love a good pun, I had to point it out. So it's really great to have you here on the show. So a few weeks back, we announced ksqlDB. We got tons of questions, but just for context, can you start by explaining what is it?
So ksqlDB is a specialized data store that attempts to simplify developing applications that process event streams or interact with event streams. So far, ksql has been simply used as a way to build kind of stream processing pipelines using a SQL dialect. And then you typically materialize state using these queries as a table. So we gave these new these kind of queries a new name. We call them push queries now. And in short, what we did with ksqlDB is we also announced that applications can now interactively at low latency query this table state. And these are what we now call as pull queries. So you're now able to both do two kinds of queries on the same system.
Yeah, so basically we started with Kafka streams, where you could build stream processing apps, but it was time consuming and you had to know Java. Mm-hmm. Then we had ksql, which allowed you to write those apps with SQL. Mm-hmm. And now we're adding those new types of queries that really allow you to look at it as a database.
Right. Yeah. And by the way, so the one thing I want to point out is that we're not claiming that ksqlDB is going to replace every other data store out there. In fact, in this release, we made it super easy for you to export your table state. Typically, you replicate it out to an external store as an end of a stream processing pipeline to serve to the application. You can still do that. We've even made it a lot more easier to do that by integrating Kafka connectings and sources directly into ksqlDB as well.
So basically, if I want to actually join data from MySQL and from Postgres and from Oracle, I can put it all in Kafka and use ksqlDB to run queries.
So one SQL statement to pull the data in, one to transform it, and then another SQL statement to export it out. Then you can also use another SQL statement to query it. The goal here is to simplify stream processing architectures for really mass adoption.
It sounds simple. I mean, 4 queries and I have an ETL system. What can be better?
All right.
So really talking about, I'm thinking ETL, but really you talked about building applications. So what kind of applications would I build?
Okay, this is a very, very good question. And for the actual use cases, we don't actually have to look too far. We can just simply look at what people do with stream processing today out in the world. And then it'll be kind of clear that how ksqlDB fits into this ecosystem. So first, if you attended like a lot of these tech conferences, and then you see a lot of these,
I may have.
You may have, yeah. You see stream processing talks, and if you attended enough of them, you'll see like a pattern emerges, right? So most people have databases, and then they have a business object, say orders, or some transactions that they're processing. You normalize them into a bunch of tables in your favorite RDBMS. And then they use a stream processing technology on the other side to kind of like piece together, join these streams, and then piece together this business object again, right?
Yes.
So in essence, you're kind of like a simple cache of the business object that you build on the other side. For these kind of like simple use cases, we already have this state replicated inside RocksDB, inside ksql. Streams already. So you can simply use ksqlDB to interactively query the state without needing to have another external data store integration.
So even without, if you don't have stream processing, if you look at business apps, most of them have to do all kinds of queries to gazillion different APIs and databases to, as you said, to create a single business object.
Correct.
So we really allow you to kind of cache the business and then query it.
Correct. And then streamline it all in just like simple SQL, right?
Yeah.
So that's one. The other use case is kind of like the marquee stream processing use case, right? Everyone uses stream processing for fraud detection, anomaly detection. That's become like
the most common thing, yes.
Right? And then if you kind of like drill down into these applications and look at what they usually do, they usually listen for an event. Say let's take a concrete one. Say you want to build an alerting system where you're looking at some business metrics and you want to alert if, say, sales drops in a given store or something like that. So you can use the push query to kind of keep pushing you these metric events as they happen. And then when you can write your business rules on what your alerting rule is. Say maybe you want to alert on a specific store doing less than 100 orders a day, you come up with your own thing. Then when this alert fires, then you're now able to interactively query, like issue a pull query to kind of fetch additional information. Like for example, you have another table materialized in ksqlDB, which has some historical context around the store.
Yeah, or what other stores in the area are doing.
Correct. Yeah. Something to drill into the alert. Right, and if you think about this right now, the way to implement such an application, you have to piece together the push queries come from your stream processing system, and then your interactive query usually goes out to another database. You have to somehow put these together, make
and
sure
it's never consistent. And what if the other database is down?
All those things, right? And this seems like a very simple thing that people should be able to build today. And unfortunately, it still requires a lot of moving pieces today, right?
Yeah,
that's something that
I'm also thinking like operationally, we run our cloud business and I may get an alert for high CPU, but immediately I want to check, did someone create a lot of new topics? Did someone suddenly really increase throughput for something specific? So really having this alerts and context together seems incredibly powerful for pretty much every use case in the world.
Correct. This is a very common use case,
yes.
Right? The third thing is a lot of people like to use like stream processing and then kind of like dashboard, like visualize data, right?
Yes.
So right now, the state store that we have is probably not well suited for kind of high dimensional sort of dashboarding, but you can, if you have less than say 5 dimensions in your data, right? Take a normal retail application. They're just trying to monitor, again, the same example.
Money in, money out, and how long does it take for the shipment to arrive to the store? Yes.
Right. So you can actually just write a push query to materialize fully materialize sort of the dashboarding dimensions, and then just issue a query, interactive query to plot that. In fact, we are hopefully we will be open sourcing a Grafana plugin, which essentially integrates with ksqlDB and lets you do this very
easily. And I love that it's Grafana because we all use Grafana on top of Prometheus for our monitoring metrics dashboards, and this basically makes it really easy for us to get events straight from Kafka, straight from streaming applications. So that'll be like, it's almost like you thinking cloud first.
Okay, cloud first indeed. I think Grafana definitely we picked because, well, to be honest, I'm more familiar with Grafana for the same reasons. But this is just one thing that we are building to just show that it can be done. I'm pretty sure.
One day we'll find out what retailers are using and then we'll build that. If you use ksqlDB for retail and you want to build this nice dashboard, can you please contact us, let us know that you're doing it and tell us what you want us to integrate with so you can have the same great experience that I'm going to have when the Grafana plugin is released. So when ksqlDB was released, Tim Bergland did a demo and posted it on YouTube. It immediately became internet hit, and I'm basically going to go over a lot of questions that this video generated. So starting with Hussein Nasser, who said, "Great demo, Tim," which, Tim always had great demos. Is it safe to say that ksqlDB is just another consumer of Kafka, or is it another deeper Kafka abstraction? Thanks. By the way, loved your podcast interview with Software Engineering Daily. So yeah, Tim also does great interviews apparently, not just as an interviewer, but as an interviewee. But for the question, is ksqlDB just another consumer?
No, I think it's a lot more complicated than that. But this is a great question and a pretty deep one. So let me take some time to kind of like dig in. A good way to look at ksqlDB would be as a distributed data store, which uses Kafka as its write-head log. So if you study architectures for any distributed data stores, take Apache HBase or even like MySQL cluster, I mean, they usually have a few components, right? One, you first have some state like which is indexed and stored on disk that you're serving queries out of. Then you need to figure out the way to sort of partition the storage across multiple servers, and then have a fault tolerance mechanism when servers fail. And then ultimately for the fault tolerance to work, you need some kind of replication of data as writes happen.
Yes.
So the other servers are caught up with the storage and so the other ones that they are gonna.
And usually the write-ahead log is for recovery, high availability replication,
right.
And then you have data files
right.
with the indexing.
Right. So going back to this, so it turns out we already had a lot of these pieces already. So in ksqlDB, the indexing and storage is provided by RocksDB under Streams. And Streams also provides the replication of this kind of index storage across different kind of Streams instances. Kafka provides partitioning and fault tolerance. So high level, we put these together.
We already had a distributed data store, we just didn't say that.
Right. So we put these together under like a SQL language, and we not to say that we are like, we don't have any more work to do. We have a lot of work to do, but the core pieces which are tried and tested, we already had, and that's how ksqlDB is built.
For me, it's kind of exciting because you take those components, basically taking RocksDB, taking Kafka as a log, and building this distributed database on top of it. Basically, if you read papers by Facebook, they already did that internally. They have their own distributed database on top of ksqlDB. On top of RocksDB. So basically, ksqlDB is like taking Facebook architecture and making it available and easy to use for everyone, which is always a good thing.
Yeah, you can also look at it like that. Yeah.
Another question from the same famous demo, Sayed Hussein says, nice, it will be really helpful if we get more examples on Git. So we have all those use cases. I'm guessing that more examples are coming to Git on how to do all those cool things. So yeah, watch our Git and you'll be notified via push queries of amazing new demos. Now I'm wondering if you can kind of build a connector. I think there are Git connectors, so you can probably do two ksql queries to get push notifications when we post new examples on Git.
Good hack day idea.
Yes, we do have a hack day coming up. Yeah. And same demo, Brad Eagle asks, what kind of vulnerabilities are there? And we were kind of puzzling over this question a bit. And I think my best guess is that Brad Eagle already knows that everyone will be using this for credit card fraud detection. He wants to be ahead of the game and be able to steal those credit cards. So we need to kind of help him out here.
But, sorry to burst your bubble, but the data in ksqlDB will be protected by the same kind of ACL security mechanisms that you use in Kafka to kind of secure the underlying topics. So if you're concerned about ksqlDB security, you just have to make sure your Kafka security is in place, and then you
watch CVEs, upgrade, apply patches, the usuals.
Yeah. Although I'd like to point out that there is a current limitation with the initial for the version that we recently launched. So the pull queries, the interactive queries, don't work on secure Kafka clusters. They're disabled by default. The reason is the pull queries can be performed at thousands per second, right? Far more than the streaming queries before, the push queries before. So we are still working on a very efficient way of enforcing kind of, ACLs and the security mechanisms. And there is an option to override that and kind of use it at your own risk. But this is something that we'll be fixing in the next ksqlDB release.
And if you do credit cards validation and fraud detection on Kafka, please don't enable the hack that allows you to query it without security. Wait patiently for our team of geniuses to figure out how to do it fast.
All right.
No pressure there.
All right. Well, someone's working on it. I'm fine.
Selva Kumar Esra asks, well, he first says, this is cool, which we agree, this is cool.
Okay.
Any ksqlDB client available, maybe control center.
Okay.
Yeah, what's good of a database if you don't have a client, really?
Yeah, a write-only database. That'd be fun.
You can kind of read and write via Kafka, should be enough.
Yeah, fair enough. So anyways, coming back to it, so right now ksqlDB exposes a kind of a well-documented REST API, which you can use any of your favorite HTTP clients to do push and pull queries against. You can also use a CLI to create persistent push queries like you used to be able to do before, and just interact with ksqlDB. In the coming months, I believe we'll be significantly improving the client API experience, and we are in the early stages of design. So we don't have a concrete answer for what shape or form it'll take, but we are definitely thinking through all the options out there and making sure for these use cases we have the best out of the box client.
Yeah, it's kind of a hard one because it used to be that everyone knew you have to do JDBC, and now there's so many other options out there.
Right. So so I think JDBC fits very well with the pull queries, right?
Yes.
But when you have a database where you're doing more like both pushes and pulls.
Yeah, JDBC has no push.
Yeah. So that's the pickle. So how do you usually, if you kind of bat an eye and think of push queries as triggers, database triggers, then...
But database never triggered applications.
Exactly, right? So we have to kind of think a little bit harder here. For now, it's pretty raw and open. You can use HTTP to consume the data, but yeah.
I'm just thinking that being at the cutting edge of what people can do with databases is never easy, and it does mean that the standard drivers, because they're standards, are not going to fit because what you're doing is very non-standard.
Yeah, exactly.
Naveen Sidareddy says, this is really cool. Everyone starts by saying this is really cool. I think you built something really cool,
All right.
Well, your team built something really
exactly,
cool.
That's what I was going to say.
Yes, I meant the collective you and your teammates built something really cool. Exactly. We just need the topology view from case streams of all sqls, joins, aggregates that we create. Otherwise, it will be a nightmare tracing the data. And as someone who works closely in space where you need to trace the data, I agree that if you're not careful, it could become a nightmare.
Yeah, I can't agree more.
Yeah, we will do something about it.
Yeah, this is something that even we face every day for when we operate ksql. So something to actually trace the data and the topologies. Just keep watching this space.
Yes. At least now we have so much to do that you'll never be out of work.
Yeah. Finally have work.
Yes, it's all interesting problems. Every one of those requests is kind of big, meaty, interesting. Yes. So something that I've personally been super curious about, that's not questions from the internet, that's my own morbid curiosity. So if you start thinking of ksqlDB as this kind of a distributed data store, obviously the first thing you think about is hey, there is caps, there's different trade-offs and guarantees. What guarantees do I get?
Okay. ksqlDB will be a highly available and eventually consistent data store, which we feel works well with the kind of use cases that we mentioned before. Although I often get asked, can we provide stronger consistency guarantees for it to be a CP system? Actually, the reality is ksqlDB uses the underlying streams architecture, right, for state replication and storage, as I mentioned before. And that is today CP as it is.
Yes.
Until if a streams node dies, and then you can't actually query the state until the other node fully kind of catches up and recovers. Yeah,
and it has all these exactly one semantics and transactions. It's something that banks use.
Correct. But the at the moment the unavailability window is actually much longer than what we would typically kind of want it to be.
Yeah.
For it to be like a useful kind of CP system. When you say CP system,
well, it's still useful. I mean, people use it.
Yeah. I'm not saying as a data store.
Recovery takes more than you want it to.
Correct. And to reduce this window, we actually need more fundamental changes in Kafka. Like, for example, when the active streams instance is producing to the changelog topic, we want this produced to be only committed when, say, the standby acknowledges, or enough standbys acknowledge this, right?
Yes.
The day we get there, then we would be able to offer more stronger consistency.
The good news is that I hear a lot from the Kafka community is that people really want the consumer acknowledgement, because people who come from the messaging world, this is kind of how messaging used to work.
Correct.
And a lot of people miss it. So yeah, I think that if you'll put out a keep out there with this improvement, you'll get a lot of support.
I see. Yeah, I think with this, I think we should be able to eventually also do consistency.
But for the specific use cases we had in mind earlier, you're saying that actually highly available is a better trade-off, and you're going towards that.
Correct. Exactly.
Yes. Okay, now we have two non-ksqlDB questions that we really wanted to answer. So the first one is, when we did the release for Apache Kafka 2.3, Tim Berglund did a video, and Vinay Kumar watched the video and had a question. He says, "Hi Tim, thank you so much for your explanation. Can you please provide your thought on the latest Kafka version 2.3.1? So I'm not Tim, but my team worked on Kafka version 2.3.1. It is really good. We put in tons of bug fixes, tons of improvements. Some of them are performance improvements. So in general, it's a highly recommended release to upgrade to. It should be much more stable than whatever it is you currently have running in your Kafka system." And Vinay is smart, so he says, "I'm looking to upgrade my Kafka from 2.1.0 to a stable higher version. I suffered from cluster performance issues with 2.1.0. Producers report Kafka delivery fails and disconnects. So I want to know which version is best for performance improvements without any breaking changes of existing config and functionality." So Vinay, good news and bad news. The good news is that we did make improvements to producer performance specifically in Kafka 2.3.1. So you will enjoy upgrading to this version. The bad news is that getting high performance out of Kafka is hard. And if you don't want to touch any of the existing configs and functionality, there may still be performance issues that were not going to be solved by Kafka itself, that you could get better performance by changing configuration, looking at things like how many partitions do you use, how many consumers, how many producers, how well batching the producer do. Performance is complicated, and it's incredibly rare to get better performance just by upgrading. Although you can get worse performance just by upgrading if you upgrade to a version that has bugs.
Fair enough.
So yeah, we basically recommend upgrading to 2.3.1. As you said, there's good reasons to do it. And then early January, we're going to release a blog on how to tune your performance, how to achieve low latency at scale, which is an incredibly difficult and complex issue. And we will show lots of benchmarks and exactly what happens in different scenarios. So you may have a fun project for the new year to make your deployment even faster.
Even I look forward to that blog.
You can actually, we're looking for reviewers.
Okay. All right.
Okay. We got a reviewer for the blog post. Fantastic. Yes. You can also, we can also share our load test mechanisms. It's also kind of fun.
Okay.
Okay. And another question. Tim Berglund did a video explaining what is Apache Kafka. I didn't watch it, but now I'm kind of regretting not watching it, because I'm like,
you knew what Kafka was.
What is Kafka, right? What is that thing? So if you are listening so far in the podcast and you haven't figured it out yet, that's a fantastic video to watch. Jeremy Connor watched it, and he said, "The only problem with Confluent Cloud is that the maximum retention period is currently 1 month, which means for usages which want to persist their events in topic forever, it isn't a viable option." So first of all, Jeremy, as someone who works on Confluent Cloud, I want to thank you so much for saying that the only problem is our retention policy. This is an easy problem to fix, and we like that our only problems are easy to fix. So I'll take that as a huge compliment. So first of all, just to correct the facts, we do support compacted topics, and if you put stuff in compacted topics, the latest update to every key gets stored forever. It also means that you can use our Confluent Cloud with ksqlDB, which requires those compacted topics. Now, we have kind of looked at the way we build in the cloud, and we noticed that we do what we call pay-per-use or pay-as-you-go, which means that you pay for your storage. And if you want to keep data forever, it means that you're actually going to pay us forever. So we are now highly incentivized to allow you to store data forever and definitely longer than 1 month. So basically you will see those restrictions change in the near future. Okay, we're kind of done with the questions, so you get to enjoy a few more compliments.
All right.
ksqlDB demo got a few things that are not questions, but actually people being excited. So we have Manoj Kitty. He basically commented and said, fantastic. So yeah, we agree, it is kind of fantastic. And to the same demo, someone called ED said, whoa, OMG, just whoa, 5 exclamation points and a thank you. It sounds like he's kind of excited. Okay. And he does use this puppy as his kind of icon, logo in emoji. I don't know, what do you call those things in YouTube? Avatar. Okay, so his avatar is this really cool puppy with
wearing sunglasses.
Yes, so I'm kind of like all the cool dogs like ksqlDB.
Well, I'll definitely let the team know that we found our
user base.
User base.
We're always looking for a user persona. Apparently, puppies with sunglasses is where it is.
Well, thank you. I'll definitely pass this on to the team.
Yeah. And thank you so much for being here to answer all of those fun questions.
Yeah, it was super fun.
And thank you everyone for having all those good questions, sending them over to us, watching our YouTube shows, watching the demo. And really, if you use ksqlDB, if you have use cases, if you use it for retail, if you use it for fraud detection, if you want cool new features and integrations, it's kind of something that's new, and we're excited to add things that our users want. So definitely let us know, and we will work with the community to make ksqlDB ever more awesome.
Right. And the final thing around that is, I think most of the engineers in ksqlDB are hanging out in the Confluent community Slack. So yeah, you just
So I saw there's actually 2 channels, right? There is a ksql channel and there's a ksqlDB channel.
Yeah.
Which is the cool one?
ksqlDB.
So you guys are on the ksqlDB one.
Yeah. So we also do our development discussions out there in the ksqlDB dev channel. So yeah, all of us are there.
And there is also obviously the GitHub that you can open issues and enter discussions and.
Yeah.
And I'm assuming that contributions are welcome.
Yeah, we're definitely looking to grow the community. This we feel is a kind of a good step towards sort of, bringing again stream processing to mass adoption. I think we need a lot more help. So yeah.
Maybe I will pick one of those for a hack day.
Awesome. Let's do it.
Let's do it.